Hey everyone. So in the last few notebooks, you've been learning how to use NLP with clinical text and how to extract clinical concepts from a clinical text document and then look for negation, other things, etc. So in this notebook, we're going to put all of that together and run our NLP system on a bunch of discharge summaries from Mimic, and then store it into a database and use it as structured data, which is really the ultimate goal of NLP. So we'll start by importing some of the libraries that we're going to use. And here's kind of an overview of what we're going to be doing. Okay, so first we'll load our model, and that's all written out for you here. And then if you want to customize your model like we've learned how to, we can once again go through the target matcher and the context component to customize what is being extracted from the text. So the first thing we're going to do now is we are going to get some discharge summaries. So make sure that you change the username here to be your actual username. Type in your password. And then what we're going to do is we're going to go to the note events table in Mimic. And we're going to query two fields, the subject ID and the text, and we're going to limit to where the note type is a discharge summary. So if you remember back to earlier in the semester, you all read through an example of a Mimic discharge summary, and now we're going to pull a bunch of those and start to use them as actual data. Okay, so let's go through and just see what our NLP does right now. So we're going to start with just a few examples. We're going to look at just the first 5 rows, and we're going to process these texts with our NLP. Okay, this takes a few seconds. We're starting with a small data set because NLP is kind of an expensive computational process. Okay, and then just like in last notebooks, we're going to look at these visualizers, and we can kind of just scroll through and see what's being pulled out here. So as a reminder, this is the statistical model, so even though we haven't added any rules, it's still extracting a lot of concepts. And you can see it's extracting these problems, treatments, just like we saw in previous notebooks. One additional thing that this notebook has is it has the section headers. So if you noticed up here, we loaded an additional component called Sectionizer, and like you probably saw when you looked at the discharge summary before, clinical notes are often broken up into these little mini sections. So like this is the social history, talking about kind of like their upbringing, this is their past medical history, etc. Okay, so as you can see, it's missing certain concepts, so you might want to do a little bit of improvements. And you don't have to do this for the homework, but if you really want to dive into NLP, you want to make sure that you're extracting all the concepts. So let's get in the past medical history, I can see 3 concepts that are missing: lung cancer, high cholesterol, and low pressure. So let's add some target rules to match those. So let's start with lung cancer. We'll call it a problem. And let's see, the way that it's spelled here is actually lung CA, and CA is going to be an abbreviation. So to match both, let's write one of those fancy patterns, where we'll say that the first word has to be lung, and the second word we will say can be either CA or cancer. Okay, now we can add that to our target matcher. And what we have to do is we have to add the target rules here. And then we can go up and reprocess. So again, this will take a couple of seconds, but I want to just make sure that it has these concepts added. Okay, and you can see now lung cancer is being extracted. And if you'd like, you can do the same thing with high cholesterol, any other concepts that you find in here. Okay, so once you're done, we are ready to deploy our model. And so after you've developed an NLP system and done some validation, come to understand, trust your model, you deploy over a large corpus. So we're going to take all 100 of these discharge summaries, and what we're going to do is we're going to process them with our NLP, and then we're going to actually write them into a new database. And so a lot of this is going to be kind of handled under the hood. We're going to import this helper function called write NLPDB. So you don't have to worry about what's happening, but it's going to process the texts and then write them out into a local database. So this takes like 1 to 3 minutes. So I'm going to pause this right here and resume when it's finished. Okay, so that took me about 1 minute 20 seconds. And let's just kind of quickly, a lot gets printed out here, so let's just kind of quickly look at what happened. So if you want to see the original, oops, I'm sorry. If you want to see the original, like what was kind of happening there, you can see that there's this folder called helpers.py in your file, and this is the function that you called. So if you want to see more specifically what was going on, you can look there. And so what happened here is that our NLP processed our 100 documents. It took 1 minute 20 seconds. And then we created a new connection to a local database, which, if you see now, there should be a file in your folder called nlp.db. And it created a new table in that database called ents. And then for each document, it wrote some number of rows into that ents table. Okay, so now let's use this database that we've created. So SQLite 3 is a library in Python for using SQLite, which is, like it implies, kind of this lightweight version of SQL, where you create like a local file and just use that as a database. So as opposed to Mimic, which is hosted on like a Google Cloud instance, this is just a file right here on in your working directory. Okay, so we will connect to this, and then let's just run a query here. So just like we do usually with Pandas, we'll write a SQL, we'll say select star from ents, ents being the table that we wrote to here, and then let's just read everything from it and see what's there. So if we look at the head of this, you can see that it's a data frame which each row represents a single entity which was extracted by our NLP. So this is the same stuff that was being highlighted in the visualization up above. So for columns, we can see that we have the text of the entity, the starting and ending spans, the label, the class that it is, and then all of these columns correspond to what we looked at in the context notebook. So whether it's negated, experienced by a family member, etc. And then the last column that we'll use here is the section category, which says what section of the note it came from. Okay, so let's see, we had 100 documents, and that created about 17,000 entities. So that shows that, like, you know, even in a relatively small data set, you can extract a lot of information when you have a model like this. Okay, so now let's get on to the actual analysis. And this is going to be the homework, so I'm going to leave most of this for you to do, but I'll walk through the first example with you so that you get a sense of of how to do this. So whereas before we were dealing with raw unstructured text, we now have this as actual structured data. So we can treat it as normal structured data just like we did in previous weeks. So we are going to query from this ents table, and we're going to do some analysis. So let's first look at the label distribution. So we extracted 3 different types of entities: problems, treatments, and tests. And let's just see how frequently those 3 different classes occur in this corpus of notes. So if you need a reminder of SQL and Pandas, I encourage you to go into the week 6 and week 7 notebooks, but hopefully you remember some of that now. Okay, so let's see. So what we want to do is we want to extract label underscore, and bear in mind that it has an underscore here, which is just kind of spacey convention. So select label underscore, and then count of 1, because we want to get the count of each label, and we need to group it by the label. Okay, if we run this, we can see that we get a data frame with just 3 rows, which has the labels and then the counts. And then we want to do a bar plot so that we can visually represent this. That's simple, just sns.barplot, pass in this information. Oh, whoops, that should be y equals. I'll fix that in the class notebook. And now you can see how many of each occur. So problem is the most common class, followed by treatment and test. Okay, so the rest of these are pretty similar, where you will write a query, you'll get some data, and then you'll plot basically the count of either certain labels or certain texts. And the different questions will ask about different criteria. So this one, you specifically want to look at treatments and then see what the most common text is. In this one, you specifically want to look at problems, but you want to filter it to ones where it's not negated or historical or a family member, etc. And then the last one, you'll specifically look at ones which are from a patient's family history. Okay, so I think you should have all the tools to work with this, but feel free to send me a message on Teams or Canvas if you have any questions. Thanks.